Okay, Carter. Heavy liquid.
Milk.
You think milk is, okay, milk is heavier than what? Would you assume?
Water.
Okay. What in life can tell us that milk is a little bit heavier than water? Aubrey? Okay. What happens when you drink milk versus when you drink water? Okay, Ava says milk makes you stronger. Raise your hand if you just feel really full. Okay, but can water also make you feel full? Okay, so Carter thinks that milk is more dense than water. Okay, Augie?
I think soap is more dense than milk.
Okay, so like hand soap. Do you guys all agree with that? Like the soap in the bathroom is more dense than, what'd you say, water? Okay, what makes you think that?
It's like thicker.
Yeah, it's like a thicker consistency, but is it still a liquid? Okay, I agree. Aiden?
Like syrup.
Syrup is a very thick liquid. Do you guys agree with that? Okay, Fisher?
Wet concrete.
Okay, wet concrete. Could that be considered a liquid? What is the liquid in it? It's water, so it's a mixture. We could, okay. And it's a very thick consistency until it dries. And then it's even thicker consistency. Elise? Okay, toothpaste. Carter? Hand sanitizer. Okay, what are some liquids that you think are less dense than water? Besides oil, we already said oil. Aiden? So Carter thinks milk is more dense. Hutley, you got one? Melted butter, because that technically is oil. Or margarine, I guess, is oil. Okay, potentially. Fisher? Okay, grease, oil, butter, we're lumping those all together. So it's harder to think of things that are less dense than water, lighter than water. It's easier for us to think of liquids that are more dense, okay? But you guys have the general idea of density now. So I'm going to go on through this slideshow. Nope, let me go. Okay. So this is a density tower is what they call this. Do you see where they come up with the word density tower? Okay, it says density is a foundational concept in physics which explains why boats float, rocks sink, and balloons fly away when you let them go. Let's talk about that one. What do we typically fill balloons with? Lainey? Helium, which is a gas. The particles in a gas are very loosely packed, which makes them less dense than any solids or liquids, okay? But what else is in the outside? We call it air, okay? What is that? Oxygen. So if balloons float through oxygen, what does that tell us about helium and oxygen? Augie? Helium is less dense than oxygen. Because if you put helium in a balloon, it lifts it up, okay? Okay, so density. How tightly packed are the particles in an object? That's the 5th grade definition. How tightly packed the particles are in an object. We're going to skip that. This has extra stuff in it. Let's go to this one. Density of a cork, of wood, and of metal. And this is relating it to water. You don't need to know the formula down there at the bottom. That's getting a little bit above our 5th grade range. But a cork, this is what I said your moms probably use at night. A cork. What is a cork? Fisher?
Like the thing inside the bottle that you pull out.
Yeah, okay, it's the thing inside of a wine bottle that you pull out. How does it weigh very much? No. If you would put a cork in water, it would float on top of the water, like almost completely out. A little bit would be underwater because it would have to be, but mostly it would be above the water. If you put a small block of wood, small block, not like a 2x4 that has a lot of mass, a tiny piece of wood, notice it still floats, but does it float as high as the cork? No, so that piece of wood in this picture would be slightly more dense than the cork, but they are both less dense. Sorry, the wood is slightly more dense than the cork, but they are both less dense than what? Water, because they're both floating in water. What about the metal? Addie? It's more dense than water. I'm assuming it's at the bottom. It's just kind of drawn funny. I'm assuming that picture has it at the bottom of that cylinder. Okay, so you can tell a lot by how something floats about it. You can tell a lot about its density. Okay, here is your notes page that you have in front of you that we are going to fill out. It shows a picture that says how tightly packed matter is, the amount of mass in a given space. So this is kind of like our particles, gas particles. We have lots of room to bounce off of each other. Liquid particles, there's a little bit of space so that the particles can glide and slide past each other. And the solid particles are tightly packed, and what do? They vibrate in place. They don't have a whole lot of movement. So, and it shows that gases are the least dense, and then they go up to the more dense solids. So solids are the most dense. Gases are the blank dense because the blank particles are not tightly packed together. Braylon, what do you think goes in those two blanks?
Gases are the less dense.
Okay, let's use least. Least dense because this is a new word. Not really new word. We haven't really used it in this way. What are the particles made of? Elise? Does that make sense? Because the atoms particles? We're on the right track. Augie? No, that's atom. Matter. The matter particles are not tightly packed together. So they're the less dense the particles, the less tightly packed they are, the least dense the object. Solids are the blank dense because the blank particles are packed very blank together. Addie J. Most dense, okay? Because the matter particles are packed very tightly together. Okay, then we get into relative density. Objects of the same state can have blank densities. Lexi? Different. So all liquids do not have the same density. All solids don't have the same density. They all have different densities. This is why some solids float and some, what, Carter? Sink. Good job. If you pour several liquids into a graduated cylinder, which is just a tall, skinny cylinder, if they have different densities, they will stay what, Kinley? Okay, separated. They will stay separated. They will stay separated. So they won't mix together. The more dense liquids will do what, Lainey? Sink. Good job. Gabe, what will the less dense liquids do? Float. Okay, then they give us a picture. And let's add to that. Sorry, I was just looking at my notes. They will sink will they necessarily sink all the way to the bottom? Like think about look at the picture at the bottom. Like the blue one. Let's say the more dense liquids will sink. Will they sink all the way to the bottom?
No.
How far will they sink? Addie, what do you think? Okay, but I have to say it in a way that works for all of them. So I would have to be able to talk about like the blue, dishwashing liquid, the milk, the liquid metal. Hutley?
Until they meet one that is more dense.
Okay, so he said until they meet one that is more dense. Do you guys agree? So we will put they will sink below the less dense liquids. So they will sink below the liquids that are less dense than them. They'll sink below the less dense liquids. The less dense liquids will float. Addie? Above the more dense liquids. Good job. So more dense goes up or down? Down. Less dense goes up. Now it says use the picture to answer the following questions. I'll give everybody a second to catch up. I was going pretty fast there. Everybody there? Okay. So on the picture, it says blank is the most dense because it blank. Kinley, if I'm looking for most dense, where are your eyes looking? The bottom. So what is the most dense? Sugar syrup. Sugar syrup is the most dense because it is, Carter? At the bottom. If we're looking for most dense, our eyes always go to the bottom. The second one says blank is the least dense because it is blank. Mason, what do you think? Where do we look for least dense?
The lamp oil.
The lamp oil, because it's where?
The top.
Lamp oil, okay, because it is at the top. So most dense, we look at the bottom. Least dense, we look at the top. Everything else, we got to pay attention to the words. Blank, blank, and blank are more dense than dishwashing liquid. So our eyes should go to dishwashing liquid. Okay, and that's the one directly in the center. We are looking for ones that are more dense. I want you to underline more dense. More dense, where do my eyes go, Lainey? Down or up?
Down.
Okay, because they're more dense than dishwashing liquid, which means they're heavier than dishwashing liquid. So what are we looking at?
We're looking at milk, liquid metal, and sugar syrup.
Yep, and I think that first blank is your guys is a little bit longer. It doesn't matter. I'm going to write milk, liquid metal. I'm shortening the name of it. Liquid metal and sugar syrup. Yes. Yeah, it doesn't matter what order, because it doesn't ask for them in order from least dense to most dense. It just asks which ones are more dense than dishwashing liquid, because they, how do we know that just by looking at the picture, Hutley?
Because they're lower.
Yeah, they are lower. I'm going to put below it. below it. More dense, we're looking down. Less dense, we're looking up. Now, I'm going to add something in. I want you to write this down in the margin at the bottom. I want you to write a paper clip, and I'm making this up. I just want us to have an idea. Is less dense than syrup and more dense than liquid metal. I want us to draw where that paper clip would be in that cylinder. Because remember, solids, we could put solids in there. Some of them would sink, some of them would float. If I put a paper clip in there, if this is true, a paper clip is less dense than syrup and more dense than liquid metal. When I drop that paper clip in, would it go all the way to the bottom of the graduated cylinder?
No.
Huntley, where would it go?
It would go in between sugar syrup and
Yeah, just draw an arrow like right here. And then let's just draw our little paper clip. Just draw a little spiral. Or just write the word paper clip. Okay, so our paper clip, it would kind of sit on top of the sugar syrup. And I don't know if that's true. I haven't tested that. But there are some solids that would float. They would look like they're floating on top of some of these liquids. What would, if I dropped like a pink eraser in there? Do you think it would go all the way to the bottom?
yes.
Probably. What would happen when it got to the syrup? Like when I dropped it in the top, what would it do? How fast would it go? Through the top? It would probably go pretty fast. Where would it maybe start slowing down? Yeah, I've never touched liquid metal. Have you guys? Okay, but we are familiar with syrup. When it hit the syrup, it would probably still continue to go down. It would just slow it down a bit. Can you guys picture that? Would it go pretty quickly through milk? Yeah, so we're pretty familiar with most of the top ones. Edible oil, I'm assuming that's like cooking oil versus lamp oil. Do you guys know what lamp oil is? In old lamps, you had to put oil in it to light them, like before there were like light switches. And now even like, what are the camping? I have battery operated ones. Lanterns, yes, thank you. Lanterns, there's oil that you can use, but now there's battery operated ones. So everything's electric and battery operated now. But before that, you needed lamp oil. Okay, does this make sense? I have a little half sheet check-in that you're going to do for homework over density. Okay, we have about 10 minutes left. You will all finish this density worksheet before you leave here. Okay, you all have your math worksheet in here right now. So if you finish science, you can just transition and work on math till RTI time. Okay?